Hello everyone, and welcome to this webinar BIM for engineers. My name is Matea and I will host this webinar for you today. The company I'm coming from is Baldini Studio, located in Zagreb, and we are regional representatives of various software solutions for the construction and architectural industry. Since 2004, we are working on digitalization of construction industry and implementation of BIM workflows in design studios. Here you can see the list of all the softwares we represent. And today I will show you how to use BIM softwares, more precisely AllPlan Engineering and SCIA, which are unique BIM solutions for engineering that gives you unlimited creativity and generates efficient project documentation. For the beginning, let's say some facts about Nemetschek Group, the group that actually created AllPlan. Nemetschek Group was founded in 1963 in Munich. It has a total of 15 brands and around 2.5 million users in 142 countries across the globe. And also it employs over 2,000 people from all over the world. Before BIM, a process looked more like the scheme on the left side, where project members communicated with each other with a lot of back and forth needless document sharing. It created a lot of unnecessary setbacks in terms of communication and project management, because each member had to communicate with every other project member. There was a lot of wait time for certain information to be gathered and processed before its implementation. With BIM, the situation looks entirely different. Each project member communicates with all the other project members through a standardized format named IFC file. IFC is something like a digital PDF that contains all the information readable in any other BIM software, regardless of which BIM software it came from. Now, simultaneous communication between project members is possible. Therefore, time is saved and we can concentrate on other issues that appear on construction sites. Moreover, the entire concept is standardized by ISO standards. There are several levels of BIM implementation. Level 0 represents generation of CAD documentation for 3D object description. Level 1 represents creation of 3D models from which the 2D documentation is generated. Level 2 represents the collaboration between the project members based on unique standardized format of exchange, IFC, which enables conversion or so-called translation of digital models to other softwares. Level 3 represents upgrade of BIM level 2. It's based on active project sharing throughout the entire project lifecycle while working online, so-called working in cloud. So there are several types of models in BIM projects that are commonly used in the BIM world. Some of those are, let's say, sub-model engineering that consists of a structural model, calculation model, and reinforcement model. Below each picture, you can see our softwares that we use in creation of such models. So today I'm going to show you a quick presentation of AllPlan engineering for creation of 3D models and reinforcement, and SCIA for structural analysis. If you want to be more successful and more productive in construction industry, you need to be able to create fast and sufficient 3D models and, of course, 3D reinforcement. Engineers can create detailed reinforcement drawings easily with this AllPlan engineering solution. So AllPlan engineering has several main advantages, and these are efficiently and accurately modeling and reinforcing building structures, associatively legends, documents, up-to-date documents, and professional visualizations, and also precise materials takeoff for accurate costing. Sorry. Okay, so now let's see how in AllPlan engineering, how to work in AllPlan engineering and do the 3D reinforcement. In this short video, you can see some kind of predefined 3D reinforcement, so-called form finding or Python part elements. This is pre-designed in software to automatically adjust to concrete edges. These are coming with all the necessary reinforcement which you can adjust to all your needs. There are numerous types of it, like columns, openings, girders, foundations, and so on. First, we select the element we want and place it inside its section. After that, we define reinforcement parameters like diameter, quantity, bar spacing, and concrete cover. And those settings also, of course, can be easily changed afterwards. You can also manually place the rest of the reinforcement and use tools like copy, move, or mirror to place the bars, for example, on the other side of the wall, like here. In this animation 3D window, you can see in animation view all your placed reinforcement. Next, I will show you how to manually model the girder reinforcement. For each element, you'll need a few, for each architectural element, you'll need a few cross sections to place the desired reinforcement. First, we select closed stirrups, define all the parameters, and place it in the cross section of the beam. Notice that the stirrup adjusts automatically to the edges of the girder cross section. And now this is when we place it in the other view, we can change the bar spacing or set the number of bars. Okay, we can also use a custom-made bars for longitudinal reinforcement. Just stretch it according to the element edges, and you can immediately place its label. Next, we need to place the longitudinal reinforcement in a cross section. And you can see that the bars are automatically placed on stirrups so that we don't need to calculate concrete cover manually. You can see your reinforcement in 3D animation view so that you can always check the collisions between bars and easily fix any mistakes. Okay, so now when you place your reinforcement, so this is bottom area of the beam, And when you place all the bars, you can easily label all the bars. So of course, for labeling, there are few types of labels. Okay, so next we will see how to place span reinforcement and span meshes for, let's say, walls and slabs. In this video, you can see the slab reinforcement. First, we select all the slab edges to place the edge reinforcement with all the parameters defined in this pop-up window. Okay, and after that, we need to define the area reinforcement in the first, let's say, in the bottom layer of the slab. So we define the type of mesh, concrete cover, overlaps, and so on. And then we can do the same for the upper layer of the slab. And then we can make visible all the reinforcement we input here. And check all the collisions in animation window. Now we will see how to place some reinforcement and then generate schemas and associative legends. Here we can also see some predefined 3D reinforcement for wall corner, the same way as described in the previous video, in the first one. So this is it. It's done pretty automatically. And for the middle part of the wall, we can use the bar area reinforcement. Set all the parameters and define the area of the wall we want to cover with these bars. We can immediately label it, and we can do the same for the other angle of the bars. Okay, so we can see it in the animation window, and of course we can mirror all the reinforcement to the other side of the wall. Okay, so now we can also place schemas, associative schemas that come with predefined labels. We can just click on bars we want to label it with schema, and that's all we have to do here. And of course, we can generate reinforcement legends that are always updated as soon as the changes are made. So it's completely associative with the model. Next video will show you reinforcement reports. So once you are done with the reinforcement modeling, you can easily generate all the needed reports